Good afternoon slash evening slash morning, everybody. It is time for our August 2024 Akka.net Community Stand-Up. Gregorius is with me today, and unfortunately, he is recovering from a nasty cold, so he's a little worse for wear in the speaking department. So I'll be covering some of his material for us today. Gregorius, you be sure to chime in if I screw something up.
Will do.
All right, so let's dive into our first thing. We'll go ahead and start with. We have a lot of release activity we're gonna cover, so we'll go ahead and start from the top down and kind of wade into this a little bit. So the first thing we should talk about is the work that's been going on with Akka.Persistence.Sql. So if you haven't kind of kept up with it, we have a last year, about a year ago, we basically started the process of trying to retire the Akka.Persistence.Sql.common library and all the plugins that are built around it. We haven't formally deprecated them on NuGet yet. That's something that we need to do. We also need to deprecate them on GitHub. We haven't really done that. We're kind of largely still supporting some of that stuff, but we should probably start the process of doing that sooner rather than later. What I've got here is a number of releases that we've done on this plugin, and I'll go ahead and pull this up. So we've been making a lot of improvements here to kind of support some of our paid customers as well as our open source community users. First, we basically made it so that if you we fixed one like Akka.Hosting bug that was kind of minor right here, but we fixed a couple of more important issues in 1.527, namely auto initialization of the tables. If you're using Akka.Persistence query and regular Akka.Persistence side by side, there was a race condition where if Akka.Persistence query started first and the tables weren't initialized, meaning this is like this would happen a lot in like local and test environments where you didn't have any data yet. Basically, the Akka.Persistence query side of things could just completely fail because there weren't any tables initialized. So Gregorius fixed this, and he also brought us up to code where now we properly on Akka.Persistence query will go ahead and include tags on the events that we're querying back. So that's all up and running properly now as well. The other bug that got fixed, and this was done by a member of our community, Luca, found a really subtle bug that caused really large delays in the journal sequence actor. The journal sequence actor is responsible for basically enforcing ordering on the read side. And long story short, we're using the wrong interval value, and this could result in really big initialization delays when we're trying to replay things from the journal. So that got fixed in 1.526. And this same user went ahead and provided us with a performance report comparing how much better Akka.Persistence.Sql is versus its predecessor, Akka.Persistence.SqlServer. Let's take a look at that real briefly as well. So we included a link to this in our newsletter that we sent out to everybody yesterday. But the basic gist of this is that if they did a test involving writing 2,000 events to a journal that needed to be read by about 35 different event processors, so 35 different Akka.Persistence queries or actors that are using an events by tag query here, that for doing projections, this is sort of what the difference in performance looked like. So for running this test over Akka.Persistence.SqlServer, the database capacity was saturated for about 10 minutes, even though the actual writing of events was done within a few seconds. The journal reading that data took a tremendous toll on the resources. So basically, the high overhead here was from the projection side of things. And basically, it took an aggregate execution time. This is basically summing up the execution time for all the queries in parallel, added up to be about 4 hours. So this is the overhead from, let's say, the control experiment here. And Luca went ahead and provided sort of the query plan that ended up getting executed from the old plugin. But when using Akka.Persistence.Sql, if I go ahead and take a look at the aggregate performance graph here, you can go ahead and see that we're running at like 100% utilization for looks like about 20 minutes roughly. If we take a look at using Akka.Persistence.Sql instead, this is the exact same workload. All the only thing that's different is the Akka.Persistence plugin. The entire test concluded in 42 seconds instead of 42 hours of cumulative execution time. So you go ahead and see here, there's a spike in resource utilization, and yeah, it kind of disappears pretty quickly. And there's some more data here on some of the basically durations of some of these queries that are being executed. You can see the difference in query execution plan here. And long story short, it basically resulted in a 350x improvement in total aggregated execution time to insert the events and then run all the queries to go ahead and project them back into the output. Now, they're not even using the tag table in Akka.Persistence.Sql, which would boost this up even more than it currently does right now. So that's one other, let's say, sort of improvement they didn't leverage, but still we get an overall performance improvement of 350x from Akka.Persistence.Sql. This is a pretty good ad for why you should go ahead and upgrade. And one of the things that we link to in the newsletter, and we'll also link to it, I guess, as a card on this recording once it comes out, is we have a migration video on the Petabridge YouTube channel that'll talk you through how to migrate off of Akka.Persistence.SqlServer or Akka.Persistence.Postgres, whichever one you're using, and will help you migrate onto the newer Akka.Persistence.Sql plugin. So that's something I'd recommend that you all take advantage of. Let's see. So we've covered this. Next is Gregorius's big project, some of the Akka.Management work. So in Akka.Management 1.527, we refactored all of the Akka Discovery plugins to use kind of a new marker interface, iDiscovery options. If you're going to be using Akka.Discovery for doing things like bootstrapping Akka.NET clusters or doing the Akka.Cluster client, let's say, sort of integration with Discovery that we added in 1.526, you will need to make sure that you have upgraded to Akka.Management 1.527, or none of that will work with the newest versions of Akka.Hosting. So that's something that you'll want to take advantage of. So go ahead and make sure you upgrade there. Otherwise, most of the major changes that were made to Akka.Management we kind of covered last month. This is basically making it possible to run multiple discovery plugins side by side, one for cluster bootstrapping, another for cluster client. We kind of already covered that in July, so I'll move past that. Next, we have Akka.Hosting. So we upgraded Akka.NET 1.527, of course. We did that in all of these plugins here. But the biggest things that we added support for was, first, we made it possible to go ahead and use the new cluster client Akka Discovery integration. So we added support for that in 1.527. So if I go and open this pull request here, you can go ahead and see some of the documentation for this. And I believe we have live documentation up on the main Akka.NET website that shows how to use Akka.Hosting for this. Is that correct, Gregorius?
That is correct. Yes.
Yeah. That's live on the Akka.NET website. If I go and pull that up here, that should be under, if we go to clustering, cluster client,
Cluster client.
and we scroll down to, let's see, where is this? When the cluster cannot be reached, contact auto discovery using Akka.Hosting. I think we probably need to make this its own like H1 rather than H2, so it appears in the right spot in the header down here. So we probably need to fix that. But
Yeah, sounds good.
yeah, but otherwise, yeah, we have this all documented in the main Akka.NET docs on the website. So that's all available there. Let's see. And then the other big thing that we fixed in Akka.Hosting 1.527 was the way we were applying sharding settings was, so a member of our Discord noted that we were doing this incorrectly. Basically, we were overriding global HOCON every single time someone updated a shard region setting. That is the wrong way to handle this. Instead, we need to be basically updating the cluster sharding settings object under the covers. So that way, essentially, there's no cross pollination between, let's say, one shard region that uses remember entities and another that doesn't. So that's all been redesigned now. So it works as intended, where basically each shard region can be configured individually. If you need to customize the distributed data stuff that cluster sharding uses, you can go ahead and basically customize that in a separate HOCON blob. Honestly, you will never need to touch this unless you have a super duper weird set of circumstances. So I would say this is not something you should be messing with. But changing the shard region settings, that's something that people need to touch all the time. So you should be messing with that. Okay, so that's Akka.NET 1.527. Let's get into the really big ticket items, namely Akka.NET 1.527 and 1.527.1. If we take a look at 1.527.1, we basically just fixed a null reference exception that happened inside custom logging implementations. So that's kind of a fairly sort of minor update there. But the really big update came with 1.527. Let's pull that up. So 1.527, we fixed two really significant bugs. Well, actually, they turned out to be two really significant bugs, but were both really the same. And that is the Akka.Cluster Tools.Singleton issue around singletons moving when they weren't supposed to. And another one around Akka.Cluster sharding, observing duplicate shards and duplicate entity actors as a result. Both of these were fixed in 1.527. And if I pull up the Petibridge blog here, I have, yes, a blog post and a YouTube video that goes into excruciating detail on all of the work that went into not only like reproducing these problems, but actually identifying how to fix them. These bugs are both about 10 years old. They've been there since the introduction of Akka.Cluster tools into the Akka.net framework. So every version of Akka.net prior to 1.527 is affected by this. I think the reason why these issues didn't get discovered until basically about last September was because I think the number of people who've been using cluster sharding has increased a lot as a result of Akka.Hosting making it a lot easier to use that functionality. I also think that people have gotten a lot better about adding telemetry to their projects. I think this is kind of a measure of people getting successful using open telemetry and other telemetry solutions like application insights in their programs. And so as a result of that, I think this bug's probably been happening, but it's been very difficult for people to observe it for some time. What's gotten better, I think, is there's a lot more people using it now, and there's a lot more people using cluster sharding now, and a lot more people who are able to observe this type of problem when it happens. The basic issue here, as I kind of detail in this blog post, is a split brain that formed. And if I scroll down a little bit, let's see. We basically discovered that the sharding coordinator, this is the actor that is ultimately responsible. Um, this is the actor that's responsible for making shard allocation decisions inside Akka.Cluster sharding. So we have a YouTube video that we'll go ahead and add a card for in the recording here. But we have a YouTube video that kind of explains how Akka.Cluster sharding is intended to work. The shard coordinator is a cluster singleton actor whose job it is to basically try to maintain an even distribution of shards throughout the cluster. The reason why we have shards in the first place is that shards are usually scaled to the number of nodes that you're hosting the sharding system on. So if you expect to have at like peak load 10 nodes that are all hosting, let's say, user entities or device entities, kind of depending on what your use case is, you're probably going to want to multiply that number of nodes at peak load times 10. And that's going to be like the rule of thumb for how many shards you should have 10 times your your number of nodes. Well, that would be 100 total shards in that case. The shard coordinator has a much easier time reasoning about where to place 100 shards than it does reasoning about where to place 5 million entities, if that's the number of entities that you have. So the sharding system is designed to help compress the amount of like location decision making the system needs to have down to basically a much more manageable number of units of work. That's the whole kind of basis for having sharding in this fashion. So the shard coordinator's job is deciding where those shards get homed inside the system. The problem that we suspected after we eliminated a bunch of theories was that there was a window of time where there could be two different shard coordinators both making decisions about where shards were allocated inside the cluster. Now, one other thing that we kind of noticed is that all the users who reported this bug were using distributed data as the state storage mode for cluster sharding. Distributed data was basically the default. It's not currently the configured default for cluster sharding, but it's what we recommend that people use because it avoids some of the problems that the persistence mode had. Namely, it eliminated the need to potentially clean up bad data in the event that your cluster abruptly experienced a termination of some type. So there was a lot of advantages to basically using distributed data. But one of the weaknesses that it had would be that it's an eventually consistent data model. And we use a type of distributed data sort of CRDT, conflict-free replicated data type, called a last write wins register. So we have this, I'm not going to go and pull up the source code here, but basically we have, I guess I could, screw it. Let's do that. We'll go to the Akka.NET repo, go down here. And I think I know from muscle memory where this code is now, since having spent so much time looking at it recently. If we go to let's see, it should be the shard coordinator. Then we have the shard coordinator states. Maybe that's not that. Maybe it's just called state. State initialized. Coordinator state. Here we go. This is what I was looking for. All right. This coordinator state is basically just a bunch of immutable dictionaries that include, here's the shard ID, here's an actor ref that points to that shard. We need this for message routing. Here's where all the shard regions are and which shards they host, blah, blah, blah. These will get synced together when we're using distributed data using what's called a last write wins register. The idea behind this is that this register is really good if you have, let's say, a relatively complex object that needs to get synced in multiple places. The most recent version of that object overwrites the oldest ones. That's what last write wins stands for in the system. So the last write wins register is how Akka.Cluster sharding, when it's using its distributed data application system, is designed to synchronize. One little subtle implication of that is you can potentially have, if you have two coordinators running at the same time, one coordinator can overwrite the other state. And there's no merging of states that occur using that CRDT data structure. If you're using Akka.Persistence as your state coordinator mode, the anti-corruption layer in Akka.Persistence, which we have in like the new Akka.Persistence.Sql plugin, and in some of the other ones like Redis, that will kick in and detect that there's two different journals, both trying to write data for the same persistence ID. And that system will cause both of the coordinators to crash, and only one of them will get recreated under that scenario. So Akka.Persistence kind of had some built-in protections against this, but DData didn't. It turns out basically this was really a problem with how cluster singleton handovers were done. Was really the issue here. It wasn't even a sharding bug at all. Actually, it was a bug with the component that sharding depends on, cluster singletons. So the problem here really occurred, and I explained this in a lot of detail in the YouTube video in the blog post here. But the problem basically occurred that if I scroll down a little bit, we basically were able to use Phobos, that's our open telemetry component for Akka.NET, to observe this happening in real time. We would end up with two coordinators during a period where the old coordinator was in the process of exiting the cluster. What happened was the new coordinator would go ahead and basically get a notification that the oldest coordinator was leaving, and it would try to start the handoff process. But if we had already had another coordinator handoff less than 20 seconds before, which we were in this scenario, this is basically, imagine like a rolling update scenario is what's happening here, where we're cycling out all of the nodes and restarting them pretty quickly. The problem would occur if that rolling update allowed us to reboot nodes in place and like basically reboot two nodes in under 20 seconds, which your Kubernetes is perfectly capable of doing. So when that would happen, the new cluster singleton would contact not the current cluster singleton that's leaving, but the one before it, who is actually a brand new node that's been rebooted. And when it got all the handover messages, it'd say, why, yes, you can go ahead and hand over from me because I've never been the singleton. And as a result of that, we would basically have a handoff where two nodes that weren't even involved with the current singleton would basically agree to start a new one, and would end up with a split brain that would last for about 10 seconds. So what could happen is we can have the cluster singleton that was exiting and the cluster singleton that was staying both make shard allocation decisions concurrently, and you end up with some split brains and some duplicates that way as a result. Now, this problem would resolve in most cases because the entities that were basically housed under the old shard coordinators allocation decision making would eventually stop receiving messages and would get killed off after a couple of minutes. But if those cluster singleton, if those sharded entity actors were using remember entities equals on, then that problem would last forever potentially. And so we had cases where users were reporting things like, I have entity actors that are connecting to MQTT brokers, and rather than my digital twin getting 100% of the messages for the IoT gateway it's connecting to. Now it's only getting half of them, and it's sharing the other half with another copy of itself, which means that we have a data consistency problem now. So this was a pretty severe bug, and we have fixed it. We basically hardened the cluster singleton manager code where it had a data freshness issue is basically what happened. Now we're using the freshest data possible, and we can ensure that the handoff works over and over again. And as I mentioned down here at the very end, after it took us a couple of tries to basically identify exactly what was going wrong. But after we fixed it and we patched it, before we ended up merging that pull request back in to the Akka.net main repository, I went ahead and I tested about 7 to 8,000 shard coordinator movements concurrently across several different environments in our test lab, and we were no longer able to reproduce it. Normally, we could reproduce it after 10 to 12 coordinator movements. So we're pretty confident that we've completely, exhaustively eliminated this bug. So, as Houston said here, software engineering's first ever actual case of humble bragging. Well, thanks. It was a lot of work, but this is a really important bug for us to fix. You have to be able to trust when Akka.cluster sharding says there will be exactly one copy of this entity. That has to be true in order for that system to have any credibility at all. So that's why I spent like 70 hours in the span of a month tracking down that bug. Gregorius, you probably also spent at least 30 hours helping me on that stuff.
Yeah, it's a coordinated effort.
Yeah, so it was definitely a team effort. Our customers, by the way, who helped us by submitting logs and giving us detail, showing us screenshots from the telemetry systems, they were also totally essential in helping us track down this issue as well. So that was truly a team effort to go ahead and track this down. So that got shipped as 1.527. We also got rid of, while we were at it, the consider app version functionality from the cluster singleton manager for basically the same reason. This could also result in a split brain where there were multiple different cluster singletons active at the same time. We decided, you know what? Even though it's a nice idea to be able to go ahead and rehome the cluster singleton when a node with a higher app version joins, we're just not going to take that risk. So we're just going to move back to having a single factor for making decisions about that. So that's all taken care of. We fixed a number of other kind of like mutability issues that were done with the cluster singletons as well. We finally shipped Gregorius's big project he worked on over the month of July, which is making it so the Akka.cluster client can now use Akka Discovery to identify cluster receptionist instances. So this means that you don't need to have seed nodes for this system to work anymore. You can use Akka Discovery just like how you would for bootstrapping a cluster. He has some pretty detailed documentation on that here. We already kind of looked at that a little bit. We solved a couple of other problems with 1.527 in addition to all of these. First, we improved Akka.cluster gossip serialization performance. So that uses like 40% less memory than it did before. There were a lot of like duplicate link queries and things like that. They're all allocated their own collections. We kind of streamlined some of that. We fixed a potentially nasty bug with the actor materializer in Akka streams. We also made it so the also two-stage Akka streams will now throw exceptions properly if you configure it to do so. And we tried to fix some configuration issues with Akka distributed data. Looks the user who reported this, owner Grumis, looks like we still got a little bit of work to do to kind of get that fully cleaned out, but we're working on it. So all of that got taken care of as part of 1.527. The last couple of things I wanted to touch on before we wrap up today, let's go ahead and change banners, talking a bit about some upcoming releases and some other projects that we're working on. One big thing that we're doing, and I think we've got links to this in Discord, and we've also been tweeting about it. It's also out on our mailing list. We're going to go ahead and share some of the practices we use in our test lab environment as part of a webinar we're doing next Thursday, August 22nd from 11 a.m. to 12:30 p.m. Chicago time, all about how to diagnose production Akka.net problems with open telemetry. So this is going to cover a little bit about using like Phobos to go ahead and try to gather data. It's also going to talk about like which messages might you want to be paying attention to for things like diagnosing actor crashes or distributed systems problems or lag, that type of stuff. We're going to go ahead and cover all that. So I would definitely recommend registering for this if you're interested in it. If you aren't able to attend live, you'll still get a recording afterwards. And then finally, I did want to talk a little bit about our test lab. So I mentioned this a bit in our July community stand up. Go ahead. I have our, let's say, live Grafana dashboards here for some of the stuff that's running inside our lab environment right now. Looks like the only thing I have in our lab currently is our draw together sample, which is what we used for our webinar about Akka.net and Blazor. So that's all running in there. But basically, more or less what we've got going on. In fact, let's see if I can pull up one of our test lab repos. Here we go. This isn't quite working just yet. I just merged this in 30 minutes ago. But one of the things that we're kind of working on building out right now is a larger repository of one-off reproduction samples for chasing down performance issues and distributed systems bugs. So, for instance, our all of our work we did on trying to investigate this duplicate charting issue, we have a set of reproduction samples for that. We also have some reproduction samples for things like that giant DDoS style socket leak issue that Akka.Management had. We were able to fix that problem because of some of the custom telemetry that we have running inside our test lab environment. This new repository we're working on here, these are all kept private because they have access to things like our virtual private network. So we basically like make VPN connections when we're doing pull request validation and other stuff like that. So we don't really want this open to the public, but we're doing things like basically deploying continuous idle CPU measurements. That's kind of one of the things we're working on here. We want to be able to measure kind of the background radiation of Akka.cluster and kind of see like, okay, how much CPU utilization does an Akka.NET cluster that has no workload, what does that take up when we're running on x64? We also have an ARM 64 cluster. We want to measure some CPU on that. One of the questions that originally inspired me to buy the hardware for the test lab and to set it up in the first place was we had a user in Discord a couple months back who talked about the idle CPU utilization being really high on their Apple Silicon laptop, but really low in their QA environment, which is using, I think, AMD like x64 processors. So it made me think that we need to have a handle for measuring that. One of the things that we're going to be doing as part of these sort of continuous experiments is trying to merge in the nightly builds of Akka.net so we can kind of get a basically an ongoing chart for seeing like what does the CPU utilization and memory utilization look like on a build by build basis for Akka.net going forward. We're kind of viewing this like an investment into some of our quality assurance that we do on the open source and also on products like Phobos as well. So we can try to kind of get a handle on its performance over time. And these are things you can't easily benchmark. Like you can't benchmark idle CPU, just like it is not amenable to doing that. The only way you can kind of observe it is actually deploying it into an environment and like pulling data from Kubernetes or something to kind of measure what's the CPU utilization look like for a cluster with no load on it. So that's one of the things that we're working on here. This is all kind of just getting us geared up to do some work around Akka.net 1.5 and 1.6 for being able to do more aggressive work on performance specifically is one of the reasons why we're building this out. We're also doing this to make it faster for us to investigate performance problems that get reported. So, for instance, there's an issue that we had some interactivity on this week, or maybe it was last week, on the broadcast hub in Akka Streams being kind of slow. We're using our test lab environment to help investigate some of that. It's just easier to do it with like open telemetry than it is with unit tests and with all the stuff that happens on kind of the normal public Akka.net, CI/CD system. That's kind of one of the things that we're developing here is a little bit of infrastructure to make it easier for us to manage some of this. So that's all I've got for us this month. So stay tuned for our next community stand up. Go ahead and make sure you like and subscribe to our YouTube channel. That really helps us grow, helps recommend our videos and live streams to other like minded .NET developers. So please take the time to do that. But otherwise, thank you very much for your time and support. We appreciate it as always. And we'll go ahead and catch you next month. Thank you very much.